Hey everyone, I'm going to show you how to interpret the M&M output data for the specific colored M&Ms from our most recent classwork. So we ran some ANOVAs. I'm referring to the output that was handed out. We already went through ANOVA 1, which was total number of M&Ms by type of M&M. So I'm going to skip down and I'm going to write up each of the other ones. So we have ANOVA 2, we have the red M&Ms, green M&Ms, and blue M&Ms. So I'm going to show you how to go from all of this information to writing it up in APA style. I provided on the classwork this outline to use, but if you don't have access to that outline or you lose it, really this is based on, so this is our stats APA style results writing guidelines. So if we go down to the page on ANOVAs, you'll notice that this way of writing up is based off of this example. All right, so it's very standard. So if you lose it, refer back to this packet and it tells you where all the pieces for ANOVA go, and here's the example write up. So this is what you would want to follow for a one-way ANOVA example. And then down here is what you would want to follow for a repeated measures ANOVA example, which we'll get to soon. So first I'm going to focus on the red M&Ms output. This is actually the most complicated one, so if you chose that one, then you had to do extra work. So we're doing red first. So this analysis attempted to examine basically whether the number of red M&Ms differed between, I don't know, red M&Ms, how do I want to say this? Differed based on type of M&M, right? So actually we could use this kind of example, do different types of M&Ms have different number of red candies inside, so we could say something like, we attempted to examine whether different types of M&Ms have different numbers of red candies inside them, right? So any sort of statement that gets at this idea is just how you complete that first part. And then let me just kind of change my font so you can see what I'm doing. Okay. So a one-way ANOVA indicated that there was something different among the three types of M&M. This something that goes here is going to be our significant statement, either a significant difference or no significant difference. We're going to skip that for now until we fill out the rest of this. Now these pieces right here, inside the parentheses, just like with t-tests, is referring to degrees of freedom. We have lots of degrees of freedom on our output, so we need to figure out which are the ones we're specifically talking about. So to fill in the degrees of freedom information, we're going to come to our test of between subjects effects table. So this one right here. In this table, we really want to isolate our independent variable. And so we are going to ignore the information from these top two lines. So let me just kind of put those in red so I know to ignore them. We're also going to ignore the information from these bottom two lines. So the degrees of freedom that go in our F, kind of before and after the comma in our parentheses, are going to be, the first one is the degrees of freedom for, move this a little bit, for M&M type. That's our independent variable in this case. So our first one is going to be the degrees of freedom for M&M type, which we see is 2. And then after the comma is going to be the degrees of freedom for error. So we see these two values right here match the values that go inside our parentheses. So 2, comma, space, 29. Then what comes after the equal sign is going to be our actual F value. So let me highlight that one in a different color. So we get that one from our F value that corresponds to, once again, our independent variable we're looking at, M&M type. So this will be 6.247 goes in there. And then lastly, we put in our p-value, and we find this, let's do yellow here, by looking at our significance that goes with, again, our independent variable M&M type. So this would be p equals 0.006. And you'll notice that I say equals because it's not 000. Anytime it doesn't say 000, we write the actual number that it says. So based on this p-value, if the p is low, the whole must go. So if p is lower than 0.05, the null hypothesis gets rejected. Is 0.006 less than 0.05? Yeah. So some people have a little trouble with this. So think about 0.05 is alpha, 0.006 is our p-value. So really we're looking here, is this 0 less than this 5? Yes. So since it is lower than 0.05, then that means we reject the null hypothesis, and we can say a one-way ANOVA indicated there was a significant difference among the three types of M&Ms, and F of 229 degrees of freedom equals 6.247, and P equals 0.006. So if we didn't have all the weird spacing, it would look really like this written up. Post hoc results, if applicable. So what do I mean by if applicable? So number one, we only have to do post hoc results if we have more than two groups. So we'll say 3 or more groups. In this case, we have 3 types of M&Ms. We're working with peanut, peanut butter, and plain. So yes. And let's just add a little, never mind. It's not easily accessible. Okay, so first question, 3 or more groups. Yes. Okay, second question, was our ANOVA significant? If the ANOVA is significant, and we have 3 or more groups, we have to do post hoc tests. So we want to say ANOVA significant. If the answer to both of these questions is yes, then we have to do post hoc test. If the answer to either of these questions is no, then we don't have to do post hoc test. So generally, if I give you an ANOVA, that's because we have 3 or more groups. So then the question you need to ask is our ANOVA significant? If yes, we need to look at the multiple comparisons table and do post hoc tests. If the answer is no, it's not significant, then you just stop right here. In this case, it was significant. P is 0.006. So we have to now look at this new table, the multiple comparisons table. In this table, we are provided with lots of numbers that we don't actually need. So let me just change all those numbers we don't need to red. So we don't need any of those columns. Really, the only column we're looking at is the sig column here. So how we read this is we want to look at, let me go ahead and make this a different color. Okay. So the way we read this is we take this type of M&M and we compare it to this type of M&M. And we come over here to the significance, and this is the significance that tells us, is there a significant difference in red M&Ms between peanut and peanut butter? This 0.078, not significant. So I'm just going to write myself a note here. Peanut, and actually since lots of them have P's, okay. Peanut versus peanut butter, not significant. and that's 0.078. Then we want to look at peanut versus plain. Are there significantly different number of red M&Ms in peanut versus plain M&M packages? So we come across here and we look here at this sig value. Yes, it is significant. So we know peanut versus plain is significant. And then let me put my p-value so I keep organized. And then if we're looking at this, peanut butter versus peanut, that is really the same as what we had up here. Peanut versus peanut butter is the same as peanut butter versus peanut. We're just saying one in front of the other one. So we don't need to look at this one at all because we already recorded that. So our third comparison we're going to do here is going to be peanut butter versus plain. So we come across here and we see that significance value is very high, not significant. So peanut butter versus plain is not significant. 0.912. Now the rest of this information is just repeats. Like peanut butter versus plain is the same as plain versus peanut butter. So we don't need to pay attention to this row at all. And plain versus peanut is the same as peanut versus plain. Right? So this and this is the same as that. Peanut and plain. So we don't have to pay attention to that row at all either. So we really only need those three values because everything after that is just repeats. So how do we write this up in our APA style? So again, we're referring back to the APA style guide handout. And so we see in here, so it's saying a one-way ANOVA indicated there was a significant difference among three classes, and then gives some information, right? The ANOVA information. Then the next part, this Bonferroni corrected pairwise piece, this is the results of the post hoc test. So we're going to start ours in the same kind of way. So this is going to be Bonferroni corrected pairwise comparisons revealed that, and we're talking about so now we want to switch, right? So we're going to want to follow this general guidelines, but revealed that peanut M&Ms, so I'm going to start with the significant one, right? Over here, the second one. So peanut M&Ms had significantly, do they have more or less than plain? To find that out, we have to go up to our descriptives. So if we're comparing peanut and plain, the mean for plain is 2.31. The mean for peanut is 0.56. So peanut M&Ms had significantly fewer, right? Because 0.56 is lower than 2.31. Red M&Ms. And then we want to put our mean. And actually we can put that, let's put it right next to where we have peanut so we can be really clear about what we're talking about. So reveal that peanut, and I'm going to put in my mean and standard deviation here, 0.56, and SD equals 0.726. Those are coming from right up here. Had significantly fewer red M&Ms than plain M&Ms. Here, let me move this M&Ms to the other side, just so they go together. Peanut M&Ms. Okay. And once again, we want to put our mean this time for plain M&Ms equals 2.31, standard deviation equals 1.182, comma, and then we want to put our p-value at the end. So our p-value, as we established down here, is 0.001. So do p equals 0.05. So Bonferroni corrected pairwise comparisons revealed that peanut M&Ms had significantly fewer red M&Ms than plain M&Ms. Then we can say something like no other comparisons were significant because this peanut butter versus peanut was not significant, and peanut butter versus plain was also not significant. So since they're not significant, we don't have to write them up in the same way. We can just say they were not significant, comma, p's, because we have more than one p we're referring to, were greater than 0.05. So if we look back at our example, right, so here it's like, oh, these were significant, these were significant. All other pairwise comparisons were not significant. My wording is a little different, but it follows the same idea. And personally, I don't like having the apostrophe in there because it's not really possessive. Anyway, I'm not that picky about it. So that would be our entire write-up. We could put these both together. If you were writing up this analysis somewhere, then your entire write-up would look like that, right? Minus all the highlighting. And that's the official write-up for red M&Ms. The green M&Ms and the blue M&Ms were actually a little easier because they did not have any significant, they didn't have a significant ANOVA, so there's no post hoc comparison necessary. So let me just write this up. So the analysis attempted to examine whether, I'm going to go with the wording up here this time, different types of M&Ms have a different number of green candies inside similarly sized packages. A one-way ANOVA indicated that there was, okay, so then we have the blank, is it significance or not, difference among the three types of M&Ms. Okay. So now we come back and we want to take, so we have F, and then our degrees of freedom goes in the box. Looking back at over here at our test of between subjects effects is where we find this information. So we're looking at this table. And we specifically want to come down to this row that is our independent variable and this row that is our error. So we need these two numbers and these two numbers, right? Because we want to follow this one along. So we would say f of 2,29 equals 1.327, comma, p equals 0.281. So this 0.281, it's above 0.05, so it is not significant. So here I'm going to say there was no significant difference among the three types. And that's it. If it's not significant, don't need to do post hoc results. And then finally, let's do the same thing, but for our blue M&Ms this time. So we want to examine whether there's differences in the number of blue M&Ms. Oh, so let me scroll down to my next one. So here's our blue ones. We want to look at our test between subjects again. There we go. Specifically at M&M type and error, which means we need these two numbers and these two numbers. So a one-way ANOVA indicated, in this case, P is 1.63, so also not significant. Among our three types, F of 2 and 29, that actually stays the same in this case. F equals 1.934, and P equals 0.163. So these are our final 3 write-ups. So depending on which one you wrote up, you'll want to compare to mine here and see how you did in identifying the right information. And that is how you go from interpreting outputs of one-way ANOVAs in SPSS to writing them up in APA style, as you will be expected to do on the next test. Hope that helped.